In lesson 2, we solved equations that had these rational expressions in them. So this homework is all about getting fluent with solving these rational equations. And the way we go about that is by getting common denominators. So if we look at number 1 here, it says solve the following equations and check for extraneous solutions. Extraneous solutions mean we might solve them and get x equals 3, but maybe we can't really have a solution of x equals 3 because when you plug it back in, you end up dividing by 0. So we have to watch out for these extraneous solutions. So we always have to check. We always have to check our equations, our solutions at the end after we solve a rational equation. So number 1 here, I have 3 over 2x plus 1 equals 5 over 4x plus 3. This is a rational equation because I have these expressions that have fractions. I have an equation that has fractions in it. And our game plan is to get a common denominator. So this denominator has a factor of 2x plus 1, whereas this denominator has a factor of 4x plus 3. So the way that I'm going to get a common denominator is I'm going to multiply this second expression by 2x plus 1, and this first expression by 4x plus 3 over 4x plus 3. We have to keep these expressions equivalent, so I have to multiply by these 1's here. But they're not just 1's, it's really 4x plus 3 over 4x plus 3, or 2x plus 1 over 2x plus 1. And in doing so, we do raise the case that we might get extraneous solutions. But now that I have a common denominator, I don't need the denominator anymore, and I just look at the numerator. And distribute that 3 in. 12x plus 9 equals 10x plus 5. Well, this is now a nice linear equation. I subtract 10x and get 2x plus 9 equals 5. Subtract 9 from both sides and get 2x equals negative 4. So x equals negative 2 after you divide by 2. But we're not done yet because we have to go back and check. Does plugging in x equals negative 2 cause me to divide by 0? No. No. So x equals 2 does check out. It is a solution. So always make sure you're checking whenever you have these equations with fractions that you're not dividing by 0. So our game plan is get a common denominator and then equate the numerators, set the numerators equal to each other. Number 2, I have 7 over b plus 3 plus 5 over b minus 3 equals 10b over b squared minus 9. So our goal is to get a common denominator, but the first thing I notice is, wait a minute, that b squared minus 9 is the difference of perfect squares, which helps me out a lot because this denominator only has a b plus 3. This next denominator only has a b minus 3, and this denominator has both factors. So to get my common denominator, I need both factors of b plus 3 and b minus 3. So this first expression over here is missing the b minus 3. So I'm going to multiply the top and bottom by that b minus 3 to get a common denominator for that rational expression. The next expression, it's got the b minus 3, so it needs a b plus 3. And this has both factors. That last term has both factors, so it doesn't need anything. So since I have that common denominator, I look up at the top. I'm going to distribute that 7 in, 7b minus 21, plus distribute the 5 in. 5b plus 15 equals 10b. I've got 12b minus 8, not minus 8, minus 6 equals 10b. I'm going to subtract the 12b over. Negative 6 equals negative 2b, which tells me after I divide by negative 2, I get b equals 3. However, warning, you can't box that in yet and be done, because you need to go back up here and say, when am I undefined? What values make my denominators equal to 0? What values are excluded? Well, that gives me negative 3. This gives me 3, and the difference of perfect squares gives me negative 3 and 3. So b cannot equal plus or minus 3. Well, wait a minute, I just got b equals 3. So if I went and plugged that back in, the second and third expression would be dividing by 0. So we reject it. We reject b equals 3. It's an extraneous solution. It's an extraneous solution. It solved the equation we got, after I got a common denominator, but it doesn't solve the original equation. So because that happened, we conclude that there are no solutions. There are no solutions to this equation because we had to reject that b equals 3. There's no other solutions. That's it. Number 3, x over x minus 8 minus 2 over x minus 4 equals negative 3x plus 56 over x squared minus 12x plus 32. Well, I see that trinomial over here, and my first instinct is to factor it, and hopefully I get x minus 8 and x minus 4. So it's a trinomial, so I ask myself two questions. I say, self, what multiplies to 32 that adds to negative 12? What multiplies to 32? Well, 8 and 4 do, and they are both negative, because that adds to negative 12, which is really helpful because I already have those factors over here, which is going to help me out a bunch. So what am I missing from this first term? Everybody's got to have an x minus 8 and an x minus 4. So I'm missing an x minus 4 from that first factor. I'm missing an x minus 8 from that second, and this term already has both. So I'm left with, distribute that in, x squared minus 4x, careful here, minus 2 times x minus 8. You're not distributing a 2, you're distributing a negative 2 there. Be careful with those negatives, they're very easy to lose. X squared minus 4x minus 2x plus 16 because I'm distributing a negative 2 equals negative 3x plus 56. If I clean this up here, I've got a quadratic equation. I've got a quadratic equation, x squared minus 6x plus 16 equals negative 3 plus 56. So when I solve quadratic equations, I set them equal to 0. I set them equal to 0 so I can use the zero product property. X squared minus 3x minus 40 equals 0. Well, when I solve a quadratic equation, I set it equal to 0, and now I factor. I factor and I ask myself two questions. I say, self, what multiplies to negative 40 that adds to negative 3? What multiplies to negative 40 that adds to negative 3? Well, if I think about that for a little bit, I'll get negative 8 and 5. X minus 8, x plus 5. Those are my factors, so what are the zeros of this quadratic equation? I get x equals 8 and x equals negative 5. But don't box those in yet, because we have to go back up to the original problem. We have to go back up to the original problem here and see what values are excluded. What values do I exclude from my solution set? Well, I throw out x equals 8. We can't equal 8. And x cannot equal 4, because if I plug those values in, I end up with a 0 in my denominator, and we can't divide by 0. Well, wait a minute. X can't be 8. X cannot be 4. So I have to reject x equals 8. It's an extraneous solution. It's an extraneous solution, so I'm only left with x equals negative 5. I only have one solution here. X equals 8 solves this quadratic equation we got, but it doesn't solve this original equation that I care about because I end up dividing by 0. And we can't have that. So always, always, always think about what are your undefined values. What values do you have to throw out because we'll end up dividing by 0. Number 4. 4x over x minus 3 minus 2 equals 12 over x minus 3. Well, that 2 is really over 1, isn't it? So everyone needs an x minus 3. So I've got 4 over x minus 3 minus 2 times x minus 3 over x minus 3, because he doesn't have an x minus 3 on the bottom, it just has a 1, equals 12 over x minus 3. So now that I have that common denominator there, I end up with 4x minus 2 times x minus 3. Be careful with that negative, please. Be very, very careful. It's hard to lose it. Distributed a negative 2, negative 2x plus 6 equals 12. 2x plus 6 equals 12. This is a nice linear equation that we can solve. This is at 2 steps now. Subtract 6. Divide by 2. We get x equals 3. But wait a minute, can I actually have a solution of x equals 3? Because if I plug in a 3, what do my denominators become? 0. So x cannot equal 3. So x equals 3 is extraneous, so we reject it. It's an extraneous solution, so we reject. So if that didn't work, there are no solutions to this equation. There are no values of x that actually solve this equation and make both sides equal. Because x equals 3 solved the equation I got after the common denominator, but it actually doesn't work for the original because you end up dividing by 0. So we have to be careful and look out for that whenever we solve these rational equations. Get a common denominator, set the numerator equal, and solve. Check for extraneous solutions. That needs to be running through our head when we see these equations with fractions.